Hi, today we'll be talking about derivatives. Derivatives are the slope of the tangent line. The slope of the tangent line is a line that protrudes from one point on a function that doesn't touch any other point on the function. Let's take a look at the equation for the slope of the tangent line. The slope of the tangent line is the limit as h approaches 0, f of x plus h minus f of x divided by h. So let's try it out with the function f of x equals x squared plus 4x. The first thing you should do is plug it into the slope of the tangent line formula. After that, distribute all the numbers. When that's finished, reorganize it, taking out all the numbers that canceled each other out. When that's done, factor out the h on the numerator, and then cross out the h that you just factored out and the one on the denominator. When that's finished, plug in 0 for h, and then you should get your answer, which is f prime of x equals 2x plus 4. At x equals 2, we could tell that the derivative of it is negative 2, as well as it is the relative minimum of the function. After taking a look at derivatives in a graphical approach, let's look at it in a numerical approach. At x equals 2, f of x equals 0. At x equals 1, f of x equals 5. At x equals negative 1, f of x equals 2. At x equals negative 2, f of x equals 9. At x equals negative 3, f of x equals 12. At x equals 1, we could tell that the estimation of the derivative is negative 2 over 3. We could also tell that the function is decreasing at this point. We could also see that the equation of the tangent at the value of x is y minus 5 equals negative 2 over 3 times x minus 1. At x equals negative 1, we could tell that the estimation of the derivative is 4 over 11. We could also tell that it is increasing at the point. And the equation of the tangent at the value of x is y minus 2 equals 4 over 11 times x plus 1. Lastly, at x equals negative 2, we could tell that the estimation of the derivative is 3 over 15. We could also tell that the function is increasing at this point. And the equation of the tangent at the value of x is y minus 9 equals 3 over 15 times x plus 2. Now we will get into finding the derivative of polynomial sine and cosine functions. Let's start with polynomial functions. So, the basic formula for polynomial functions is f of x equals ax squared plus bx plus c. Looking at a, we could tell that x has an exponent of 2. So we have to follow the equation that's shown on the board. You have to take the original value of the exponent and multiply it with x while subtracting 1 from the original value of the exponent. So let's try it out with an example. The example we are going to use is f of x equals 2x squared. So to do that, we have to multiply 2x to 2, which is the exponent for x. After that, we have to subtract 1 to the original value of the exponent. So the answer should be f prime of x equals 4x. Now for b, we will use the same exact formula. But since the exponent of x is already 1, when you're trying to find the derivative, the exponent will equal 0, making x equal 1. So let's try it out with the function. The function we're going to use is f of x equals 3x. The answer would be f prime of x equals 3 because all you will have to do is take out the x and that will be your answer. Lastly, for c, if there is no x, the derivative of that number will always equal 0. So for an example, f prime of x equals 5, but when you look for the derivative of that, it will always equal 0. So now let's try it all together. f of x equals 3x squared plus 4x minus 5. So 3x squared will become 6x, 4x will become 4, and negative 5 will become 0, leaving your answer to be f prime of x equals 6x plus 4. Something to know as well is that the derivative of sine of x is cosine of x, and that the derivative of cosine of x is negative sine of x. Lastly, let's take a look at the connections between f of x and f prime of x for polynomial and trigonometric functions. Let's first take a look at the relationship between f of x and its derivative. When f prime of x equals 0, f of x will have a horizontal tangent line, and it also might have a relative minimum or maximum. When f prime of x is more than 0, f of x will be increasing. When f prime of x is less than 0, f of x will be decreasing. When f prime of x changes from positive to negative, f of x will have a relative maximum. And the last one, when f prime of x changes from negative to positive, f of x will have a relative minimum. Now, let's take a look at a graph representing f prime of x and seeing its relationship to f of x. At f prime of 5, you could see it go from positive to negative, which means that f of x has a relative maximum at x equals 5. At f prime of 0, you could see it go from negative to positive, which means that f of x has a relative minimum at x equals 0. It is also where f prime of x equals 0, so that would mean that f of x has a horizontal tangent line at x equals 0. From the coordinates of 5, 0 to the coordinates of 0, 0, f prime of x is less than 0. So that means that is where f of x is decreasing. From the coordinates of 0, 0 to the coordinates of 4, 0, f prime of x is more than 0. So that is where f of x is increasing. So that is all we're going to cover in this video. Thank you so much for watching.